In a philosophical quarterly paper, philosophy professor Nick Bostrom at Oxford University in the UK posits that what we observe as our universe may in fact be a very advanced simulation designed by our distant progeny. It could be an ancestor simulation, said Bostrom, a simulation that aims to be a reasonably realistic rendition of the actual historical ancestors or close variations of the people creating the simulation. Now, 3 physicists at the University of Washington in Seattle are working on new ideas to test Bostrom's simulation hypothesis. In a paper recently posted on Arxiv, a scientific e-print service, University of Washington theoretical physicist Martin Savage and colleagues note that the underlying lattice structure imprint of such quantum supercomputer numerical simulations might involve dividing our observed space-time continuum into a 4-dimensional grid. Such a grid may be detectable via present-day astrophysical observations, specifically in observed energy limitations of ultra-high-energy cosmic rays, UHECRs, as well as how such cosmic rays are spatially distributed on the sky. We're just asking if indeed we are a simulation, said Savage. What signatures would this imprint upon our universe? Although current technology is only able to simulate our universe on the scale of 1/100 of a meter, a so-called future, post-human civilization should be able to completely create a whole simulated universe, of which we may be a part. Even though science fiction is rife with holographic realities and simulations used to both entertain and control, Bostrom says the fact that we may be living in a simulated universe wouldn't mean that we're any less real than biological entities in a non-simulated universe. Savage says that if our distant progeny are simulating our universe's underlying fundamental fields and interactions with sufficient resolution, then all particles would interact in the same way as they would in a non-simulation. It would all be real, said Bostrom, though our part of reality would happen to be located inside a real computer. Bostrom says if such simulations are being run, their creators are probably some form of super-intelligent post-human civilization. He says the technology needed to create such simulations is so advanced that a civilization capable of generating such numerical models would presumably have already used their advanced technological prowess to also enhance their own intelligence. As for the advanced civilization's motivations for creating such simulations, Savage says string theory suggests there's a landscape of possible universes, and each universe has a different set of fundamental forces and constants. He says it's imaginable that an advanced intelligence might want to launch simulations of all these different universes to see exactly how they evolve. Are they empty and boring? Do they collapse upon themselves? Or do they hold humans in life? Savage says that if there are patterns in the way high-energy cosmic rays are distributed on the sky that would be consistent with an underlying lattice simulation, then within the next couple of decades, astronomers should be able to detect them. The lattice would imprint itself on UHECRs, said Savage. I don't think we could prove that we're in a simulation, but we could find evidence consistent with that scenario. To prove it, Savage says we'd need other tests and other data. To that end, he notes that Fermilab has an upcoming experiment to precisely measure magnetic properties of subatomic muon particles. However, if the lattice is built on scales smaller than the Planck length, where physics as we know it break down into quantum fluctuations, Savage says the simulation would bear no known detectable signatures. So, if we're part of a simulated universe that's in its first beta testing, said Savage, then we'd be more likely to find the simulation signatures. But we would be unlikely to detect the lattice spacings of an advanced simulation.